trigonometric functions. In part 1 of my video, I've stopped at the standard angle. So let me recap what I've gone through, well, what I've shown you previously. Now, if I were to have a triangle with all the sides to be the same, meaning 2, 2, and 2, equilateral triangle, each of the angle would be 60, and if I were to drop a bisecting line, and therefore my angle here would be the same as with here, which is 30 degrees, and that would make the side here to be 1 and 1. This is a right angle triangle. By using theorem Pythagoras, this height would therefore be square root 3. So I have my 30 degree and 60 degree. Then over my right hand side here, I have isosceles triangle, 45 degree, and I define this the side here is 1 and 1. Therefore my hypotenuse length would be square root 2. So here I have my 30, my 60, 45. So these are the three standard angle, 30, 45, and 60. And you were able to find out what's the sine, cos, tangent. And then in my first part of my video, towards the end, I also shown you how to set up the table for this three angle. So over here today, on the right hand side, I would show you how to get the 0 degree and 90 degree. So you will get the all 5 standard angle. Now, to start out with, you need to recap from what you have learned. I mean, by now, actually you should know. If it doesn't know, then never mind. To get a graph for the sine, cos, tangent. For sine, cos, and tangent. How does it look like? Now, as a thumb of rule, what I have shown you will be the method of how to sketch it. So I hope you will be able to follow me closely from now onwards. Now here, to start out with, you draw a line, maybe 2 cm, 2 cm, 4 cm, 4 cm, 2 cm up, 2 cm down in the middle, 2 cm. Here is my 0. You have this cross. Then what you could do, now this is positive, this is my y, and this is my angle theta. For the sake of this discussion, I will use a degree. So once you have 2 axes, then you separate them into 4 parts. 1, 2, 3, 4. Each of them would be 90, increment of 90, 180, 270, and 360. Okay, pretty simple. 2 axes, 1, 2, 0, then 1, 2, 3, 4. 4 of them to be a standard. Then next, that will be your y. Y would be 1 and -1. Because for any sine, cos, tangent, maximum number is only 1, minimum number is -1. If you have all this, 1 and -1, and all 4 angle, 90, 180, 90 increment, then we're quite set to sketch a graph for, maybe use black, sine graph. For any sine graph, sine 0 is actually 0. So 0, down in the middle. Sine 90 is 1. Go up, the pattern is middle, up, and come back to middle. and then go down to -1 and come up here to here. This is one way to sketch it. We are not plotting it. You need to learn how to sketch it. It comes up in your paper too, and it will be some advantages if you know how to sketch it. The next way to do it is to sketch it. Now, one thing you need to know is that it's a curve, that it doesn't go straight into 1, but you imagine that you want to curve somewhere near to 1, to here, somewhere near here. I hope you can see my cursor. So what we'll do now is to sketch it is a curve up, and then towards here you try to bend, and then touch at the cross, come down, cross to here, pass through here, and then before the cross, bend, so that you have a nice curve and stop at 360. Why 360? Because I define my angle to be only from 0 degree, more than 0 and less than 360. Okay, this is standard things to do. For your own practice, then again, the second one would be 2 cm up, 2 cm down. And if you have a graph paper, that would be nice. Otherwise, you may sketch it on a piece of A4 paper. The y-axis and x-axis, 0. Go up y. I have my maximum 1, -1, standard number. Then 90 degree, 180, 270, 360. I doesn't have a ruler. If you have a ruler, then you'll be able to synchronize the scale. You can scale them so that the angle will always be the same. The reason to why I will draw this, so that you will be able to tell the difference. Okay. Now, the first one, maybe I need to label them. It's a good practice to label a graph. This one, my y, is therefore sine theta. For any sine 0 is 0. So look like S curve. This one is a cos curve. So for any cos, sine 0 is actually 1. If go up, this is maximum already. Second one will be in the middle, and then go down to the middle, below middle, and go up, and then go up. That's the pattern. Oh, it's slightly too high. Okay, no, maybe somewhere here. This is a sketch, doesn't really matter. To sketch them is you curve down to here, then curve up, and then curve up. It's a K, look like a K. And this will be the cos. So I label this, maybe I label it here. This y is actually cos theta for this range. Lastly, will be for tangent. Tangent, again, not really the same, but very close to it, but you still need those axes, 0, y, and then 90 degree, and then 180, 270, and then 360. Now, for tangent, that would be a little bit different, because for tangent, like a T, you have something called asymptote. Asymptote is where at 90 degree you have a dotted line. This is an infinity line that the curve will not touch. There is no value for tangent 90 and tangent 270, and the graph should look like. It's better for you to start at somewhere 980, because it will be here. The curve is curve here, curve down to touch at 180, then curve, don't touch at 90, curve. Okay, then middle portion of this you shift. Okay, this middle portion, this those that is on your this part is then shift to here, and the lower part shift to here. So you will get a curve trace to there. I think it's a mirror trace to there. Then it will look like this here, and then here. So that's the graph for y is equals to tangent theta. Okay, so these are the three standard graphs that you should know. In my next slide, that will be on how to change them. So come back to my left. So if you want to get a zero value to complete, to make the table complete, to complete the table, for any sine value, sine, cos, tangent, if I were to find out its a standard angle, maybe 0, in ascending order, ascending is going up, 30, 45, 60 degree, and then 90 degree. So those value, easily you'll be able to get it out from the table and also from the graph. From this table, maybe here is my theta. Okay, so as for practice exercise, since you have gone through my first video, except for this one, sine 0, sine 0, sine 0 will therefore be 0. Okay, cos 0 is 1. Tangent 0, 0. Okay, then it goes to the next column, sine 30. Sine 30 over here, sine 30 will be 1 over 2. Cos 30, cos 30 will be root 3 over 2. Tangent 30 is 1 over root 3. I think I've gone through it in my first video, so this is serve as a revision. So sine 45, so come back to 45, so it's 1 over root 2. Cos 45, 1 over root 2. Tangent 45 is 1. Sine 30 will be root 3 over 2. I hope you need to practice this, how to make this video, how to make this table at least 8 to 10 times. One day once. Cos 60 would be 1 over 2. Tangent 60 would be root 3. Whereas 90 degrees, sine 90 is from here. It's over here. Sine 90 is 1. Cos 90 is here. Where you get 0. And tangent 90 is infinity, undefined. Right? So this is what you should know. I hope you spend some time to learn how to construct this table, because it will be really, really useful when it comes to solve questions. Now, there are of course sometimes in question they don't want you to express this angle in degree form. Instead, they prefer you to be in maybe pi form. So 90 degrees is actually pi by 2. This is plus half of pi, so it's pi. Plus another half of pi is 3 pi over 2. 360 is 2 pi. Okay, you may use accordingly, but it depends on questions how they ask you about this. All right, now next that would be on identities. I think next part would be the identities. I think I make use of the table what I have shown over here. So for identities, there are a few identities that you should know. I don't know how you know it, but you should know. First would be the famous one called, if you have a sine squared of an angle, and then this angle I will put at A, number A, plus cos squared of the same angle, number, the sum of them is actually equals to 1. Alright? You may prove it. Okay, you may prove it, of course. Say if A is 30 degrees, say, example, sine squared 30 degree squared, I mean you may write here, or if you have number, then I will do it here. If you have number, then you do it here. If it's an unknown, then you do it here. Okay, plus cos of the same angle. Let's find out what's this number. So what will it be? So therefore it will be based on our standard angle I've shown you earlier. Sine 30, let's refer. What is it? Sine 30 is half, and cos 30 is root 3 over 2. Right? That's why it's useful to have this table. So therefore, you know, this is sine 30 is 1 over 2 squared plus cos 30 would be root 3 over 2, and squared, that would be 1 over 4 plus 3 over 4. You sum them, therefore is actually equals to 1. Okay, this is what happened. Now it's not limited to only a standard angle. Why I choose standard angle? Because it's easier for me to show you here. Because this is identity, it works with any angle. Right? Next, second identities that you should know, which is 1 plus tangent squared. Okay, 1 plus tangent squared A. 1 plus tangent squared is secant squared A. Okay, you may use the same method to prove that, but I don't think I'm going to do it here because it's or you may do it in your own time that you can do it. I'm sure you can do it. But if you really can't do it, okay, let's prove this example. I'm not going to use number to prove it. Let's prove it by this method. So left and right, I'm going to start with left hand side because left hand side is the most complicated one. Let's start with left hand side. 1 plus tangent squared A is therefore equals to what? You need to prove it's equals to secant squared A. So you need to prove them. So how do you do that? I will start with 1. So I write 1 plus tangent. You know, to get tangent is sine cos tangent. So it's sine cos squared. Okay? Sine cos is tangent. Sine by cos, ratio of sine and cos is tangent. So here, therefore, is actually 1 plus sine squared A over cos squared A. Squared is here already because it's not a number. So it's just unknown, so I can write that. Now, in order to prove it into equal to secant squared, secant is 1 over cos. So I need to cancel off this sine squared effect. But how can I do that? What is 1? There's no 1 here. So 1 is basically equals to sine squared A plus cos squared A. Oh no, sorry, the other way around. Now, I think I'm going to find another easier way. Now, the denominator is different because so I'm going to do times it with cos squared A. So what happened here? 1 is actually cos squared A over cos squared A, and then plus remain what is it here is sine squared A over cos squared A. So the denominator is now the same. I'm able to perform the addition. So cos squared A plus sine squared A here is basically equals to 1 over cos squared A. Why I times it? Because I want to make the denominator to be the same. If you have the same denominator, then I can sum them so that I can get second squared A, which is therefore equals to second squared A, right? That's why I separate this chapter into two videos. The reason is you need to be familiarized with tangent. Tangent is sine over cos. And then here, the first identities is sine squared plus cos squared is good one. Then I can use it here. And eventually I prove these identities. Okay? By using the same manner, the third one, you should know. But it doesn't really comes out in a SPM in the past 5 years. I hope it won't comes out. But just in case if it does comes out, so you have some idea how does it comes about. 1 plus cotangent squared A is actually cosecant squared A. Okay, this is very similar to how I prove the second identities. I think it's good also to show you how to do it. You may pause my video, take my challenge to prove it yourself. You may pause it now. Okay, if it doesn't pause it, welcome back. I hope you managed to prove this. Also, from here, based on what I've seen, left and right, choose left hand side. Based on this question, left hand side seems to be more complicated. You have 1 plus and something. Here it's only 1, it's very hard. So it's too simple. Yeah? So choose the hard one. On the left hand side is harder, more complicated one. So I choose left hand side. So 1 plus cotangent squared A is therefore equals to 1 plus cotangent squared is 1 over tangent squared A. So from based on what you have learned, tangent is sine over cos. So here would be cos over sine squared A squared. So you get tangent. 1 over tangent is sine over cos, because it's 1 over already, so you invert that. So again, from here, the denominator is not the same, it's 1, so you times both sides up and down, sine squared A over sine squared A. So plus this is remain over sine squared A. So sine squared plus cos squared, same angle, is 1. So this is 1 over, denominator is sine squared A. So 1 over sine squared A is basically equals to cosecant squared A, right? This is how normally you should know how to get this. And yeah, there are more of this kind of question in your practice exercise. Maybe you need to try 10 or 15 questions before you proceed to others exercise. Now, next would be addition and subtraction for this tree, sine cos tangent operation. Addition and subtraction. Maybe I'll put it at number 4, kind of identities. Now, if I were to have sine, I were to separate an angle, maybe A plus B, maybe 30 plus 60, right? It's sine 90 straight away, you know sine 90 is 1, but some other angle, yeah. But for our practice exercise here, discussion, I will use 90 is maybe 30, 60 or 20, 70, yeah. So how do I get the outcome? How do I do it? You can't like times it 1 by 1, but it's a kind of identities. If you were to have this, what happened is equal to sine A cos B and plus sine B cos A. Okay, you just need to know it behaves like that. You doesn't need to answer the question of why it is. No need to answer the question why, but because it's identities, it behaves that way. Clear? So this is sine A cos B, then sine B cos A. In the event that if you want to subtract sine A minus B, so you follow suit. That's all about it. Give you an example. I will use the simple example so that you understand these identities. I would say sine. I will use standard angle because it's easier for me to show you how it works. Okay, sine 30 plus 60. So sine 30 60 will be equals to sine 30 cos 60 degree plus, so I will be plus sine 60 cos 30. So from here you will be able to work out the answer because easily from previously we have made the table. Sine 30, what's sine 30? Sine 30 is 1 over 2. Cos 60 is 1 over 2. Yeah, yes, correct. They are the same. Plus 1 over 2 times root 3 over 2. Wait, do I make any mistake? Cos 30 is root 3 over 2, correct? Sine 60 is root 3 over 2. Root 3 over 2. Sorry, make a mistake. It's root 3 over 2. Okay, so you times it in over 4 plus 3 over 4, therefore is equals to 1. Sine 60 is actually equals to 1. Okay, so this is how it works. Sine A plus sine B is sine A cos B, sine B cos A. So each of the angle get to be sine once over left and right. Okay, next, fifth one. Oh, see. Let me change it back, synchronize the color. Number 5. You have sine and you have cos. Now cos will be slightly different because if cos A plus B, the answer would be cos A cos B, yes. If it were to be plus, then the outcome would be minus. Then the rest is sine A sine B. Okay? If it's plus, it will be minus. In the event when it's minus, then it becomes plus. Okay? If you insist, you want an example? Okay? Example. I think it's good to example, so you have some idea what's happening. Cos. Say, do I have some value that you know of? Maybe 30. Not necessarily be different. I want 30 plus 30. It could be the same angle because any angle, it works with any angle. So same angle. So see if it's work. Equals. You have a cos, so therefore it will be cos A, cos B. But my B appeared to be the same angle, so it's 30. And remember, it's just plus, it will become minus. Sine 30, sine A, sine B. My sine B is the same angle, so it turns out to be 30. Okay, so let's see it works. Cos 30. What is cos 30? Cos 30, based on the diagram or based on the table, that would be root 3 over 2. Cos root 3 over 2. Sine 30 would be 1 over 2. Sine 30 would be 1 over 2. So this is 3 over 4, subtract 1 over 4. So therefore is 3 minus 1 is 2 over 4, is therefore equals to half. Then you may ask yourself, cos 60. What is cos 60? Easily you know it's 1 over 2. Okay, so this is how it works. You should know this. Even if this trigonometric law is given in the exam, I mean the standard is given, but if you're not familiarized with them, it will be very hard for you to do questions, especially when you want to prove. Okay, the sixth one, you have sine, you have cos, you have tangent. Come in a package. 6. What about tangent? You have tangent A plus B. Okay, you have tangent A plus B, and they will equal to, what is it? It will be equal to tangent A. If it were to be plus, then it would be plus tangent B over 1 minus tangent A times tangent B. You just know it. It behaves like that. Okay? This is plus, this is minus. In the event, I use another color, easier for you to see. In the event, if it were to be minus, then it will be denominator will be minus, denominator will be plus. Okay? Do you need an example? Yes, I think it's better because this is interesting. Let's we use some infinity work to show you its infinity. Let's use tangent 90. So that would be a tangent maybe 45 plus 45. Oh, no, I don't want to use same angle, so that is very hard for you to see. I will use tangent 30 plus 60. Okay? Based on the diagram, I say it's infinity. Because on the graph, it says infinity. Okay? Let's prove it if it's infinity, undefined. So here, first one, draw a line between the equal sign. Between the equal sign, you draw a line, long line between equal sign. So tangent 30 plus, it will be plus tangent 60 degree 1. If it were to be plus, denominator will be minus. Okay, tangent 30 times tangent 60. Okay, if you remember the table correctly, so therefore tangent 30, what is tangent 30? Tangent 30 would be, oh, okay, draw a line between the equal sign, between the space of equal sign, draw a line. Tangent 30 would therefore be equals to 1 over root 3 plus tangent 60 would be root 3, square root of 3. Okay, 1 minus tangent 30, 1 over root 3. Tangent 30 is equal to root 1 over root 3, yes. Tangent 60 is root 3. Now, you don't worry about what is here, but here, root 3 cancel off. 1 minus 1 is 0, so that would be 1 minus root 3 plus root 3 over 0. You cannot have something over 0 because that would be undefined. Okay, so that's make tangent 90 to be undefined. Okay, this is undefined. Right? So I managed to prove it to you. Tangent 90 is undefined mathematically and also graphically. Okay, is it all about it? There are others variant of it. Oh yeah, before I forget, there's one more. The 7th. You should make your own notes from here based on what I've shown you. Number 7th. Always forget about this one. The cos. I don't. Okay. Let's. What happened here? Sine 2a. Okay. Sine 2a would be therefore equals to sine a plus a, correct or not? So a plus a, I think I've done it earlier, maybe here. So a plus a, so it's just like this one. it's not really a law, it's an application. So therefore there will be sine A cos A sine A cos A plus cos A sine A cos A sine A. So they are the same, you know. Okay, put some bracket, don't want to confuse you, easier for you to see. They are the same thing. So therefore sine 2A is actually 2 sine A cos A. Times them. Okay. If it were to be the sine 2A, nothing's too special. Okay. You may prove it, but I think you're not quite familiarized with it, so I'm going to do it. Quite boring doing it. Let's go to the next one, cos 2A. Now this is something different because cos 2A from the definition that will be, I think, worth doing, because this is cos 2A is basically cos A plus A, because A plus A, so therefore there will be cos A, cos B, but B is A, so cos A plus is minus sine A sine B. They are the same angle, so just sine A times sine A, cos A times cos A. This is cos squared A minus sine squared A, because sine squared A is the sine A times sine A. So you may be able to do some changes from here and there, because cos squared A, from what you have learned earlier, cos squared A plus sine squared A is equal to 1. So you may make use of that, our first identity, either substitute into here or here. If I were to substitute into here, what we will get? You will get 1 minus sine squared A is cos squared A minus sine squared A. If we will substitute into here, then this turns out to be 1 minus 2 sine squared A. Okay? Or it's possible also, if I were to substitute into here, then that will be equals to cos squared A, that will be cos squared A, the original, minus sine squared A is 1 minus cos squared A. Negative, you times it in, then it turns out to be equals to 2 cos squared A minus 1. Okay, so to summarize, this cos 2A is possible equals to cos squared A minus sine squared A, and also it is equals to 1 minus 2 sine squared A, or it's also equals to 2 cos squared A minus 1. So there are 3 possible outcomes. You need to just know it, and you just know it by luck, or you just make some exercise, do some exercise, get used to it. Okay, let me give you an example. I think I'm going to have 3 parts for this chapter. So second part of it will be identities and also the usage. Let me proceed to some example. First one, example, how can I, how questions should come out in the paper 1. Question in paper 1, example, how do you solve those questions? Solve a question like 3 cos 2x equals to 8 sine x minus 5, and given the range 0, x 0, 360. Okay, now this kind of question, they ask you to look for what's the value for x. Based on our over here, you might have some problem method you don't know how to do. In order to start out with, doesn't know how to do, it's easy, it's normal, because to start with, look at here and here. This is cos 2x. This is something that you may able to expand. Cos 2x, you may expand this. Once you expand this, bring it over, you equate to 0 and solve for x. That's all about it. So, to solve this, so therefore 3 will be 3. Cos 2x, this is sine, so you want to convert this cos 2x into sine. What will it be? That will be 1 minus 2 sine squared x. Okay, you convert this to here based on the law. Then it's equals to 8 sine x minus 5. Then you have sine already, you bring it over, this is negative, bring over this side, so your sine squared is positive, so it turns out to be 6 sine squared x plus 8 sine x plus 3 minus 3, that will be minus 8. That will be equal to 0. This is factorize them, maybe 3 divided by 2, so you sine squared x plus 4 sine x minus 4 equals 0. Then from here, you need to make use of Form 4 chapter 2 factorization. You assume, all you need to do is to assume this whole term as your x squared. This is x, whole term as x. Just like in your Form 4 chapter 2 quadratic equation. How do you factorize them? 3x squared plus 4x minus 4 equals 0. Okay, how to do that? So 1, 2, 0. You may use a calculator, of course. Then it turns out to be you get 3. So I would say this is 3x. So this is my sine x is x. So I get here sine and here sine x. So 3 sine x squared. What's the number? Minus 4. You sum them, you get 4. I can think of only 2 and 2. So you get minus, get plus. Over here, that would be, so that I'll get minus 2 plus 2. So minus 2 plus 6. So you get plus 4. Okay? In order for the product to get 0, there will be 3 sine x minus 2 equals 0, or sine x plus 2 is equal to 0. Give some marks if you write this, you get some mark for this. Now, based on here, on the left hand side, my sine x is equals to 2 over 3, but here sine x can never be equals to minus 2. So this is something, no solution. It cannot be. The maximum is only negative 1. If you still remember our graph, its maximum is 1, minimum is negative 1. So negative 2, then it is not valid. So you focus on here. Sine x is 2/3. Use a calculator for the range 0 to 360. Okay, I'll do it here. Sine x equals to 2 over 3. So you know that add sugar to coffee basic angle, it will be positive. Here positive. So this is the angle. What is this angle? From a calculator, add sine. So therefore, angle of x, acute angle, the first one would be 41 degree, 41 degree, 49. 49 minutes. So this is here 41 degree 49. The same goes with here 41 degree 49 minutes. So but our angle is always measured from 0, which is my 0. So here to here you find out. So all you need to do is to use 180, subtract this, and therefore the value would be 138 degree 11 minutes. Okay, so therefore this is the answer, final answer. Alright, paper 1, it shouldn't be so hard. My third part of my video, I will focus on graph sketching and looking for solution. Stay tuned for my part 3. It will take some time for you to learn out this, to solve this kind of question. Do not straight away go to my part 3. You should give yourself 1 week to learn how to solve this kind of question before you proceed to my third part of my video. You should try about 15 questions, 15 to 20 questions over a week time for this sorts of question. With that, I hope you enjoy my video. Stay tuned to my part 3 next week.